Okay, this is going to be a video with just a few examples, some brief overview of the first couple sections in Chapter 8 dealing with rational expressions. Um, Section 8.1 is going to cover simplifying, basically reducing things, multiplying and dividing rational expressions. So let's get into a couple examples here. First off, just think about when you have a basic fraction like this, no variables, something you've done since, elementary school. Um, what we're really doing is here, if we're looking to simplify or reduce, you're looking to see like what can you divide out of each piece. Okay, so you can think of 36 as we know is 6 times 6, and I know that 60 is 6 times 10. Okay, so this might not get done in one step, but at least we can see so far that 6 over 6 really equals 1. They kind of cancel each other out, something divided by itself. So those are gone. And then what we can recognize with the 6 over 10, they're both divisible by 2. So the 6 is really 2 times 3, while the 10 is really 2 times 5. Um, so again, we get another set of something divided by itself that'll cancel out, and we're just left with a 3 over 5. Okay, and you might have recognized, we could have maybe done that faster from the very beginning, just taking this original thing and dividing top and bottom by 12. If you notice the greatest common factor, those was 12. You could have got down to the 3/5 a little quicker. Um, but again, you don't always have to do it all in one step. It's, sometimes best, but just look for something that's common and then kind of divide it out. So these rational functions and expressions are going to work the exact same way. So something like this, before we get into one actually, this is something that, once you're in the habit of canceling things and you might think, can we go ahead and just cancel? I see a +7 and a +7. So let's see what happens. Can we just cancel those out? Is that right? Does this thing really just equal 3 over 13? Okay, and I guarantee if you're going too quick, there's times when you're going to do this, and hopefully we recognize that's not true. Okay, the original expression was 3 plus 7 over 13 plus 7. And if we actually do the math on there, 3 plus 7 is really a 10. The denominator is really a 20. This thing really equals 1/2. Okay, it does not equal the 3 over 13. So the point here is you can only start canceling things or crossing things out and reducing if it is a multiplication problem, like this previous example. We had something getting multiplied. There was a 6 as a factor. Okay, that's why we always say factor first. Okay, these are factors here, the 6 and the 6. And if there's a common factor, then you can cancel. Okay, there was a common factor of a 6 and a 6, so those got canceled. So not a common thing being added or subtracted like in this case. Okay, so just be careful with that. That was a little introduction. Let's look at some with some variables in here. This is a multiplication problem. We see the little dot there. We want to start simplifying. That's what the directions would be. So what I would do, okay, one thing I can do is look for any common factors in the numerator and the denominator. So for example, I'm looking to see this thing's already a big multiplication problem. It's 4 times 8 times n. The bottom is really 3 times n times 3 times n squared. Okay, there's no plus or minuses. There's nothing on there that I need to factor. It's already a multiplication problem. So what I notice right away, there's a common factor of an n. So that can get canceled out. Let's see, that leaves us, if we clean up where we're at, we have a 32 up top, multiplying that out. The denominator will be a 9n squared. And I don't believe there's anything that we can reduce with the 32 over 9 part, and then the n squared part, there's no n's up top. So that's simplified as far as it can go. Okay, really all we could do there was reduce one factor of n. Okay, how about another one? Let's do one with a little bit more work, a little messier problem. So a couple things on this one. First off, I notice it's a division problem, so that's just going to make us actually multiply by the reciprocal. That's the best way to handle division problems like these. So we'll rewrite it. Okay, but what I want you to focus on in this one, there's a bunch of things that can be factored. Okay, this top left term here, or terms, that's factorable. It has a common factor. Okay, same thing with the term below it, the m squared minus 16. So let's start factoring every single piece. We always want to factor first. So in that top left part, I see both of those share a 9m squared as a common factor. Okay, and the other factor, the leftover piece, okay, since this was originally 9m to the third, I would need to have an m there. Okay, check the distributing, that would give me 9m to the third, minus, and then to get the 36m squared back, if I already took a 9m squared out front, that would be a 4. Okay, so that part is factored. Down here now, this one shows up in quite a bit of these problems. That's the difference of perfect squares. It's m squared minus 16. So it's technically like m squared minus 4 squared. So to factor the difference of perfect squares, it's going to be m plus 4 times m minus 4. Okay. And now that those are both factored, I can kind of see there's an m minus 4 that's going to get canceled out. But let's factor the rest first. Let's actually turn this into a multiplication problem. So I'm going to do the reciprocal of my second term. Okay, so I'm actually going to put this part is going to be the numerator. And that's going to factor into a GCF of 3m. Okay, and leftover factors, I need 3m squared, so I need another m, and I need a plus 4. Okay, and then finally this, which is now the denominator, that has a common factor also of 3m. And it has a leftover factor of m minus 2. Okay, so everything's factored. We got the reciprocal part taken care of. We are now ready to start seeing what we can reduce. Okay, so let's go through. I see an m minus 4 over an m minus 4. Okay, anything over itself equals 1, it can be canceled out. I see a 3m. Okay, those are actually two separate things, but there's a 3 times m and a 3 times m. Those can be canceled out. I see a factor of m plus 4 in a numerator and a like factor in the denominator. Okay, and that's it. Okay, so the only stuff left here, our answer is going to be 9m squared. That's the only stuff in the numerator. And the denominator just had an m minus 2. Okay, and that would be considered simplified. Okay, now I'm going to go ahead and do a couple examples in 8.2. Now this is a little different situation here. This is when we're going to be adding and subtracting. So if you remember from adding and subtracting fractions, there's a little bit more to it. So I want to go over a couple quick examples there. So let's go back again and start with a basic one, basic multiplication problem. Something similar that we did in section 8.1. If we're multiplying fractions, okay, remember we can reduce anything in the numerator over anything in the denominator, meaning this 2 and this 4 can be reduced. I can divide them both by 2. So this would become a 1, this would become a 2, and then we're left to just multiply straight across, 1 times 1 and 3 times 2. Okay, and that'll give us a final answer of 1/6. Okay, now for adding and subtracting, it's a little bit different. Okay, we need a common denominator here. Okay, we need to add the same size pieces. So this process should be familiar. We want to look for, what is the least common multiple of our denominators of 3 and 4. So I'm going to look for something that they both go into. Okay, and you can always just use their product. 3 times 4 is 12. In this case, that is the smallest one, but sometimes there might be a lower multiple. But let's go ahead and use 12. 12 is the least common multiple in this case. So now I'm just rewriting these terms. 2/3 is some number of twelfths, and we're just going to play a little game of what did you multiply by. So that got times by 3 to become the 12s, or by 4, I'm sorry. So the numerator must get times by 4. Okay, so 8/12 is another way of writing 2/3. Okay, and then on the other side here, again, the 4 became a 12, it got times by 3, so the numerator needs to get times by 3. So now we can kind of add these together now that we have the same size pieces. I have 8/12 plus 3/12. I have a total of 11/12. Okay, so we're going to do the exact same process. Throw some variables in the mix, and we're going to add some fractions, add some rational expressions. Okay, so let's go over a couple quick ones. Okay, something like this. We have 4 over 5y plus 2x over 6. Okay, need a common denominator here. So again, look at what your denominators are. Okay, 5y and 6, and we want to rewrite this problem so that the denominators are common so we can then just add the numerators. Okay, so we're going to do the same exact thing. I need the lowest or least common multiple of those denominators. Okay, one option is to just multiply the two together, 30y. Okay, is that the smallest thing that they go into? Yeah, I think it is. Okay, 5 and 6, the least common multiple there, I believe, is 30. Okay, and we need to have the y there. That's one of the terms. Okay, that's the least common multiple of the two denominators. 5y and 6 is 30y. Okay, so I need to rewrite this problem so that both denominators are 30y. So I'm going to ask myself, how did it go from 5y to 30y? There was a factor of 6. There was a multiple of 6. Oops, I guess I could put the x on that side. So 6 times 4 is going to give us a 24. So our term on the left here is going to be 24 over 30y. Okay, and our term on the right, to make this 6 become a 30y, it got times by 5y. Okay, so whatever that numerator is, it's getting times by 5y. So it's really 2x times 5y. It's going to be 10xy. Okay. All right, now we're able to add. Okay, we can add these two things together. We know the answer will always have that denominator, and we just have a 24 plus 10xy. Okay, and there's nothing to do as far as combining those. They're not like terms. 24 doesn't have any variables. 10xy obviously has x's and y's, so nothing we can do. Leave it like that. Okay, that is your answer. Okay, and let's do one more here. P plus 6 over 4p minus 20, and we want to subtract 6p over p minus 5. Okay, so again, just like when we did multiplication problems, we want to factor whenever possible. I'm looking at this denominator right here. I'm seeing it's factorable. It's really 4 times p minus 5. Okay, a little GCF there. So now my two denominators that I'm worried about, okay, the denominators are 4p minus 5, and the other denominator is just p minus 5. So the least common multiple of those two things will be our common denominator. Okay, so I'm going to rewrite the problem. I need to get a p minus 5, and I need to get a 4p minus 5. Okay, so we already have, if we use this first one, the 4 and the p minus 5, that is going to be the least common multiple of our two denominators. We needed the factor of 4. We needed the factor of p minus 5. I didn't need another factor of p minus 5 because I already had it in the first one. Okay, so what we got to do now is figure out what are the new numerators going to be. Okay, in the term on the left, its denominator already was the thing we needed. It already was the 4 and the p minus 5. So basically the numerator of that is just going to stay the way it was. It didn't get changed at all. We times it by 1 if you want. Okay, it's the other term whose denominator got multiplied by something. Okay, we really took and multiplied this by 4, didn't we, to get down here? Okay, so I need to do that up here. And 4 times 6p is going to be 24p. Okay, so now we've kind of adjusted things. We got their denominators to match up to be common. Now we can do the combination here, the subtraction part. I know the denominator is going to be 4 and p minus 5. And the numerator right now is p plus 6 minus 24p. Okay, which can be simplified. The numerator can be combined a little bit. Okay, if we have some like terms, we have 1p, we take away 24p. We would have negative 23p and a plus 6. And that would be your answer. We got the common denominator, we got the numerator simplified, and that is done.